All right, let's now talk about adding special context tokens. So previously we talked about creating the so-called vocabulary from all the different tokens in the training set, and then we used that vocabulary to create the token IDs. Now we are going to talk about extending this vocabulary with special tokens. So for example, we might want to add, depending on the tokenizer, a token for unknown words that are not in the training set. Or for example, we could indicate when there's an end of the text by using a so-called end of text token. And we will talk more about this end of text token later on when we are actually pre-training and fine-tuning the LLM. So here though, the goal is essentially to extend our simple tokenizer a little bit to handle these special tokens. And I also wanted to just show you one shortcoming of our tokenizer. So if I go up here, we defined our simple tokenizer here. Based on the vocabulary. If I have some text now that is slightly more, I would say, sophisticated. So before we used this text here. If I have text, let's say, let's do something not super sophisticated, but something different, like hello, maybe do you like tea? Is, I don't know, this a test, for example. And let's try to see what our tokenizer does when we actually try to encode this. So as you can see, there is an error now. It says key error hello. And hello is a very normal word, so why would there be an error? And the reason is because the text that we processed apparently, so the verdict here, apparently it does not contain the word hello. Now, if you are creating an LLM and train it on trillions of tokens, the chances are that this word would be in the training set. For example, here we have only this very small data set. It might not even contain simple words as hello, for example. And by the way, later on, I will also tell you more about an algorithm that can naturally handle unknown words. So for example, if the word is unknown, it will just break it down into individual characters. So maybe to show you what I mean. So if I type just something like this, you can see if it doesn't know the word, it will break it down into individual characters. But this is a more advanced algorithm. For now, how can we actually make our simple tokenizer slightly more sophisticated by handling unknown words? So what we could do is we can extend our tokens. So if we have all tokens, which were the list of the preprocessed text tokens or words. So this would essentially recreate our unique tokens from the data set. And now what we could do is we could actually extend it. So if we use the extend method on Python lists, we can actually add additional tokens. For example, we could add this end of text token that I mentioned earlier. Or we could also add a token for unknown words. So we can really add anything we like here. So just extending it. And so the difference is to what we did before is we are creating it similar to before, but now we are adding tokens that are not already in the data set. And then we would generate the vocabulary similar to before. So this is the same that we used before, like this token to integer mapping for the vocabulary. And then, let's actually take a look at the length of the vocabulary. I think before we had, let me scroll up a bit, 1,130. Now we should have 1,132 tokens. Let's double check. Yep, so we have these 2 new tokens added. And let's actually print the first or the last, in this case, the last 5 entries. We can do the first 5. They should look similar to what we've seen before. So just the special characters, but more interestingly, let's actually print the last 5 tokens in the vocabulary, and we can see we now have these 2 new special tokens in the vocabulary. In a similar way, we can now modify our simple tokenizer to actually use these special tokens. So what we have to do now is we have to essentially add a special rule to process those. So I will just copy and paste it here. So we return the string if the string is not empty and if it's in this vocabulary. And otherwise, if it's not in the vocabulary, so else, we will return unknown for this unknown token. And this way we will prevent that this modified version of our simple tokenizer crashes on words such as hello here, for example. Yeah, and this is all we do essentially. It's a simple modification, and this should actually help us to run our simple text example. Let's just copy this one for simplicity. So we are reinitializing the tokenizer. Now we have tokenizer version 2, and I will make a new code cell and then tokenizer encode text, and this hopefully works now. And yeah, you can see we now have this unknown token. So actually when we go back, let's see what happens. So tokenizer decode. Yeah, you can see now it handled the unknown tokens. This is of course not desirable if we want to regenerate the original text. And later, actually in the next sections, I will talk also about an algorithm that will make this a bit more sophisticated. It's called byte pair encoding, and I will explain how byte pair encoding handles unknown tokens.
Get this book at Manning.com.